Hi, I'm Phil with Right Rope. I wanted to take a minute to discuss rope safety and help you understand some terminology used in the rope business. Right Rope is an online rope distributor, and we have tons of different types of rope in stock and ready to ship the same business day. We have arborist ropes, industrial ropes, boating and sailing ropes, decorative ropes, and much more. Rope safety is the responsibility of the user and should always be taken seriously. There is no replacement for some good old-fashioned common sense, but it always helps to have some technical understanding as well. Ropes must be inspected before each use for damage of any kind and should be discarded if they are not in good condition. You may have heard some different terms used when talking about rope specifications: tensile strength, breaking strength, minimum breaking load, working load limit, shock loading, etc. I want to explain what each one of these means and help you understand how to safely use your ropes in any situation. Tensile strength and breaking strength mean basically the same thing when talking about fiber ropes. It is the amount of force required to cause the rope to fail. Ropes are tested by manufacturers using computer-controlled brake test machines. These machines have capstan grips that the rope wraps around. This allows the rope to be pulled until failure to get an accurate measurement of exactly how much force is required to break a new, straight piece of rope with no knots or splices. Tensile strength or breaking strength is never an indication of how much force you should apply to the rope. Minimum breaking load is the average breaking strength minus about 15 to 20% to account for any anomalies in the rope. Most ropes made by good manufacturers won't have any breaks less than 15% below the average. For example, if we have 3 break tests performed on a particular rope and the break numbers come in at 9,000, 10,000, and 11,000 pounds, the tensile strength of this rope would be the average of the 3, which is 10,000, and the minimum breaking load would be 8,000, a 20% reduction from the average. Working load limit is the most important term for someone to know when they use rope. While breaking strength or tensile strength is a measurement of when the rope is sure to fail, working load limit is a reduction of that number to be sure that the rope doesn't fail. This is the number you want to be sure you don't exceed when using the rope. There are many other factors to consider when determining the safe working load limit. Working load limit is calculated by dividing the breaking strength of the rope by a number somewhere between 5 and 12. This is called a safety factor. We typically recommend a minimum safety factor of 5 to 1 depending on the operation. The more dangerous an operation is, the higher the safety factor that should be used to ensure the safety of those involved. For example, let's say you are dragging a log across your property with a tractor. An operation like this can be dangerous, but there likely wouldn't be any serious injuries if the rope were to fail. An operation like this would require a 5 to 1 safety factor. You would divide the breaking strength of the rope that you want to use by 5 to see what the working load limit is. Let's say the breaking strength of the rope is 10,000 pounds. 10,000 divided by 5 is 2,000. The working load limit in this operation should be 2,000 pounds. You should make certain that you don't exceed the 2,000 pounds of force during this operation to be sure the rope does not break or get damaged. Another example would be a rappelling rope for a rescue operation. In this operation, there is enormous risk involved and rope failure would be catastrophic. We would recommend a 12 to 1 minimum safety factor for this operation. Using a rope with the same 10,000 pound breaking strength, divide the 10,000 by 12 and you would get roughly 833 pounds. The working load limit for this rope in this operation would be 833 pounds. Never exceed the working load limit. As you can see, the safety factor of a rope is determined by the operation it is being used for and should be determined by a competent professional. If you don't know how to determine the working load limit of a rope, seek guidance from a qualified person that understands the risks involved. When in doubt, go with a higher safety factor. There are a few other factors that should influence what safety factor you use. One factor is whether or not you are using knots and what kind of knots they are. Some knots can reduce the strength of the rope by as much as 60%. A simple overhand knot on a bight reduces the strength of the rope by about 35%. A figure 8 knot on a bight is about the best knot you can use to maintain as much of the strength of the rope as possible. This knot maintains 75 to 80% of the strength of the rope. Splicing is the best method to preserve the strength of the rope, which in most cases maintains 90% or more of the rope's strength. Shock loading occurs when a load is allowed to free fall for a period of time before the rope engages to stop the fall. An example of this would be when an arborist is rigging limbs and lowering them to the ground. He may accidentally tie off a limb with a couple feet of slack, and when the cut is made, the branch falls a couple feet before being caught by the rigging rope. This creates much higher forces than the weight of the limb by itself and should always be avoided. If there were a situation where shock loading could not be avoided, the user would want to use a higher safety factor as well as use a rope with a nylon core that has the ability to absorb some incidental shock. Another consideration is the age and condition of the rope. The breaking strength and working load limit are for a rope in new condition. As a rope gets used and ages, you should take the condition of the rope into account when determining the safe working load limit. Never use a damaged rope or one with obvious signs of wear. Most of these considerations come down to a judgment call in the field, and the user is responsible for rope safety. Don't use ropes that you don't know the history of. It may have been subjected to a number of damaging conditions. A few last common sense safety considerations. Make sure you choose the right rope for your application. Never stand in the recoil path of a rope or in the path of a moving rope. Never stand under a suspended load, and never allow any part of your body to become between a rope and a pinch point. Let me know if you have any questions, and give this video a thumbs up if you liked it. Subscribe to our channel for more videos about rope. Leave a comment with any questions or suggestions for future videos. Visit rightrope.com to get the right rope at the right price.